Welcome to Eureka Math. I'm Mr. Schenkel. This is Grade 8, Module 4, Lesson 10. Let's get started. Okay, we've got a table here. We just need to fill in some times, and then we'll talk about what this all means for us in our lesson today. Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? Well, let's continue this pattern so we can see if we get to 137.5. Just double it, 25 to 50, 2 becomes 4. And then we're just going to keep adding 25. So in 75 minutes, he'll go 6 miles. In 100 minutes, he'll go 8 miles. And in 125 minutes, he will go 10 miles. You can see that we don't have a 137.5 in our minutes column. If I add 25 more, I would get to 150, so it's somewhere in between here. But we have to figure out how to make this happen. So what I'd like to talk about is his distance, which is our y value, over our time, which is the x value. So if I take this first row, there's an arrow, kind of. And I take my distance, 2, that's miles, over the time, 25, which is minutes. I get that ratio, comparing miles to minutes. And then I can make an equivalent ratio that also compares miles to minutes. Minutes, yeah, let's make that an N. Oh my gosh. There we go, miles to minutes. And they tell me the number of minutes, so I'm going to use that for the bottom, the denominator, 137.5. And we don't know the number of miles, which is our y value. So I'm going to put that y up here. Now, we learned in the lesson today that constant speed is distance over time. So our constant speed is distance over time. And that's what we've done. We've taken in both of our ratios, we've taken a distance and put it over time, and that's equal to another distance over time. So we've created a proportion because we are consistent and corresponding with our ratios. Miles to minutes compared to miles to minutes. And now that we've done this, this should look a little familiar from our last topic where we used means extremes. This is 25 times y is 25y is equal to 2 times 137.5, which is 275. And now we can solve for y. And when we solve for y, it's going to tell us the number of miles he could go, the number of miles he would go in 137.5 minutes. So using our techniques from algebra, we're going to just multiply by the reciprocal of 25, which is 1/25. If I can get my pen to work. And balance the equation. And we're going to get y equals 275 divided by 25, which is 11. So if we were to squeeze this in here, 137.5 would be the number of minutes, and that would take him 11 miles if he walked at that constant rate. All right, so we're going to use that idea of constant rate is distance over time, and we're going to use that to set up a proportion so that we can use our means extremes technique to create a linear equation and then solve for the missing variable. Number 1. Wesley walks at a constant speed from his house to school 1.5 miles away. It took him 25 minutes to get to school. What fraction represents his constant speed? Well, remember, constant speed is distance over time. Distance over time. And you can always remember that because when you think of speed, we usually think of miles per hour. Well, that would be miles, distance, over hours, time. So if you get caught and you can't quite remember what is constant speed, it's miles per hour or distance over time. In this case, it's miles per minute. So we're going to write this ratio 1.5 miles over 25 minutes. Okay, the problem is we can't have a decimal in our numerator, so I'm going to create an equivalent ratio by just changing this 1.5 into a whole number. So I'm going to do that by multiplying by 2. And if I multiply the top by 2, I have to multiply the bottom by 2. That's the equivalence of multiplying by the number 1. And that gives me 3 miles and 50 minutes. So there's our constant rate, 3 miles every 50 minutes. And we can use that now to answer part B. You want to know how many miles he's walked after 15 minutes. Let y represent the distance he traveled after 15 minutes, and write a fraction that represents the constant speed. So I'm gonna create the proportion right now because we can do that all at the same time. So parts B and C we'll do together. So I'm going to use my 3 miles, my constant rate, 3 miles every 50 minutes. And I'm going to create an equivalent ratio that also compares miles to minutes. And I'm going to use the information they gave me. And they gave me 15 minutes that he's going to walk. So I'm going to put 15 on the minutes side, that denominator. And y is going to be my distance. So up here is the y. Now we can use means extremes. And when we do that, we get 50 times y. That's 50y is equal to 3 times 15. That's 45. And then isolate the variable. So multiply by reciprocal and balance the equation. And we get y equals 45 50ths. And if we simplify that, that is, I can divide each of these by 5, that is 9 tenths. So y is 9 tenths. Well, y is a number of miles. So that's 9 tenths of a mile in 15 minutes. Okay, next we can write an equation in 2 variables that represents how many miles Wesley walked after X minutes. So what we're going to use is his constant rate. So my equation is always going to start with my dependent variable, which is the y, equals, and then I need the constant rate, which we said was 3/50ths times x. And that will be our linear equation for solving the number of miles that he could travel, no matter how many minutes that we choose. So let's just try one. In fact, let's try this x equals 15 that we did earlier. And let's plug that in and see if we do in fact get 9 tenths. So y equals 3/50ths times x. My x is going to be 15. So we get y equals 3/50ths times x, which is 15, or 15 over 1. And you can see if I just multiply first without simplifying, I'll get my 45/50ths like I did here. So that equation will work. And then I would suggest that you simplify before you multiply to make this easier to simplify in the end. This one's not hard if we don't do it that way, but let's get in that habit. So I know 5 goes into 15 3 times, and I know 5 goes into 50 10 times. So then when I multiply, there's nothing else I can simplify. So now I can just multiply and I get 9 tenths, which is our answer, 9 tenths of a mile. All right, there's number 1. Number 2, Stephanie drove at a constant speed from her apartment to her friend's house 20 miles away. It took her 45 minutes to reach her destination. So first we need that constant speed. And remember, constant speed is distance, in this case 20 miles, over time, which was 45 minutes. Okay, and then I would like to simplify that moving forward. So when we do write our equation, I'm going to have a simplified coefficient. I can divide each of these by 5 again. So 20 divided by 5 is 4 miles. And 45 divided by 5 is 9 minutes. So 4 miles and 9 minutes will be our unit rate. Now we can write an equation to solve, a proportion to solve the question in part B. What fraction represents constant speed? If it takes her X number of minutes to get halfway to her friend's house. Well, halfway to her friend's house would be 10 miles. So I'm going to make myself a note. That's 10 miles. I'm going to use our constant speed, 4 miles in 9 minutes. And I'm going to create a proportion, an equivalent ratio that also compares miles to minutes. And we know the number of miles. So the number of miles is 10, so I'm going to put a 10 on the mile side. That's the numerator this time. And X is the number of minutes, so that X goes there. Now we can use means extremes. 4 times X, that's 4X, is equal to 9 times 10, that is 90. And then to simplify and isolate the variable, multiply by reciprocal, balance the equation. And we're going to get X is equal to 90 divided by 4. And 90 divided by 4 is 22.5. 22.5. And this is an X value, which is minutes. So it's 22.5 minutes to go 10 miles. Okay. Write a two-variable equation. Well, always our equations start with the dependent variable y equals, and then we need our constant rate, or our unit rate, and that's 4/9 x. So y equals 4/9 x. The distance, y, is equal to 4/9 times any number of minutes. So we can choose any number of minutes here, and we should be able to get the distance. Let's use the one that we were given to begin with, this 45 minutes. If I put 45 in for x, I get y equals 4/9 times 45, or 45 over 1. If I simplify before I multiply, I will get, let's see, 9 goes into 9 once, and 9 goes into 45 5 times. So we get 4 times 5, which is 20 miles. And we are able to find that that's true. It is 20 miles if he walks, if Stephanie drove 45 minutes. All right, there we go. Let's take a look at the last one, number 3. The equation that represents how many miles y Dave travels after x hours is y equals 50x plus 15. Use the equation to complete the table. So all we're doing here is using the linear equation that was given to us and substituting. We're just plugging in the value of x given to us and calculating the miles. So for this first one, it will be y equals 50 times 2 plus 15. 50 times 2 is 100, plus 15 is 115. So I can see that after 2 hours, we get 115 miles. And continuing, y equals 50 times 3 plus 15. That's 150 plus 15 is 165. And again, a little more calculating we'll have to do. 50 times x, which is, in this case, 3.5 plus 15. And 50 times 3.5 is 175. And then add the 15, I get 190 miles after 3.5 hours. And then the last one, y equals 50 times 4.1 plus 15. And 50 times 4.1, let's see, 50 times 4.1 is 205, plus 15 is 220. So we get 220 miles after 4.1 hours. All right, that's just substitution using the linear equation that was given to us. And that is lesson 10. I hope that helps. See you again next time.